or in the last session we had discussed about the partitional methods of clustering analysis. We had discussed about the taxonomy of the clustering analysis methods, and also we had discussed about the k-means algorithm. So how k-means algorithm works, where it is used, and what are the steps involved in k-means algorithm. And with an example we also saw that how to solve any problem given for k-means algorithm. So in today's class we are going to take up the hierarchical clustering part. So here hierarchical clustering produce a nested series of clusters as opposed to the partitional methods. Here we are going to create a nested clusters. So in hierarchical means, so here we have, in this hierarchical method we have two different types. One is agglomerative hierarchical clustering, so hierarchical clustering method. Hierarchical clustering method, as we said, will produce nested cluster points or nested series of clusters when compared to this partitional methods, which produce only a flat set of clusters. So here in this hierarchical clustering we have two types. One is agglomerative clustering and one is divisive clustering. One is divisive clustering. Agglomerative clustering is also called as Agnes. Agglomerative clustering is also called as Agnes. Here divisive clustering, this is also called as Diana. Is also called as Diana. So these are the two different hierarchical clustering methods we have. So here this agglomerative clustering is a bottom up approach. This agglomerative clustering is bottom up approach. Whereas this Diana or divisive clustering is top down approach. Top down approach. So here basically when we speak about this agglomerative clustering, initially it will be having n number of clusters for n different objects. In the sense, how many number of elements are present, for every element one cluster is formed. So let me take an example. So I have 5 elements A, B, C, D and E. Okay, I have 5 different elements. So when we are speaking about agglomerative clustering, we have, as it says, we have n number of clusters, n clusters for n elements. So as per this rule, how many number of elements are here? There are 5 elements. So how many clusters we should have? We should have 5 different clusters like A, B, C, D and E. These are the 5 different clusters which we have shown. Now in the next step what happens is, the distance between all the clusters is found. The distance between all the clusters is found. The distance which is having the nearest value or the smallest value is grouped ones. Suppose if I say 5 clusters are here, A, B, C, D and E. If A and B is having the smaller distance, then these two will be merged and created as a single cluster. So this becomes like this. So now these two different clusters have been merged onto a single cluster called A and B. Now we are going to check out for the distance again with A, B, C, D and E. When we consider that, we come to know that D and E will be having the smallest values by computation, any other computation methods. Now only left one is C. So this is kept as it is. Now we compute the distance, if at all the distance whichever is smaller, suppose CD is small, the distance between C and D is smaller, this becomes C comma D comma E, and at the last stage we get A comma B comma C comma D comma E. So here you can see that from n different clusters for n different objects, we have arrived at the end stage one cluster for n different objects. How many number of clusters you have created for any number of objects? At last, in the last stage of this agglomerative clustering, we have all the elements in a single cluster. This moves on in ascending order. Such kind of clustering methods or such kind of hierarchical clustering methods, we call it as agglomerative clustering. Okay, we call it as agglomerative clustering. So I said that the distance computing has to be taken place here, or the distance between two different clusters need to be computed. So to compute those distance between two different clusters, we have different algorithms, distance computing algorithms we have. Of those 5 different computing methods we are going to check out. The first one is single link. Next one is complete link. Third one is centroid. Fourth one is average link. And the fifth one is Ward's minimum variance. Ward's minimum variance. Okay, so these are the 5 different algorithms which we have to compute the distance between two different clusters. So what are these 5 different approaches? So single link approach, whatever we are doing here, we are doing it between the centroids, sorry, not centroids, between the clusters. Suppose you have two different clusters, cluster A with few points. Okay, let me draw like this. Now we have cluster B with these few points. Fine. So this is cluster A, this is cluster B. These are the points in the cluster B, these are the points in cluster A. Now single link algorithm computes the distance of all the pairs of A comma X. Distance between all the pairs of A comma X, where A is the first cluster's element, or A is the element in the first cluster and X is the element in the second cluster. Okay, distance between all the pairs A comma X is computed, and the lowest value of these two elements, or the lowest value out of this computation, is considered. So if this is my lowest link, so this I call it as single link algorithm or single link approach for distance calculation. So out of all the elements in cluster A and out of all the elements in cluster B, this single link algorithm computes the pair distance between distance between all the pairs A comma X, where A is the element in the first cluster and X is the element in the second cluster, and at last it will be taking up, or it will be considering the smallest pair or minimum distance pair from those two clusters, and that will be linked up. So this is one way. So when I say A and B, the smallest distance covered, the smallest distance between those 2 points, so these two will be merged together like that. So now the next thing is complete link. So complete link is called as farther neighbor algorithm. So complete link is also called as farther neighbor algorithm. As the name suggests, it computes the maximum distance between the maximum distance between the pair of points, and that will be considered for this. So the same thing, it will be taking for n values in here and m values here. For all nm values or nm pairs, we are going to consider the values. So we are going to consider the distance, and the farthest distance between these two clusters will be considered. The farthest distance will be considered. This is for complete link. Okay, this is complete link. You can see here, this is the farthest point in cluster A, this is the farthest point in cluster B. This distance between the farthest points of cluster A and cluster B, we call it as complete link. Next is the centroid. Okay, in this centroid, what we are going to do is, we are going to compute the distance between the centroids of both the clusters. So average values from the centroids of both the clusters we are going to consider, and we are going to put it. Suppose this is my cluster and this is this is my centroid and this is my centroid in cluster B. So I am going to compute the average distance between all these things, and I am going to compute the centroid. The distance between centroid of cluster A and the distance between centroid of cluster A with the distance with the cluster B, centroid of cluster B, whatever the distance is there, we are going to have it. So here A comma x, when I say this for cluster centroid algorithm, it will be centroid of A comma centroid of B. Okay, centroid of A comma centroid of B. So the distance between those 2 points will be checked out. Now the next thing is average link. What does this average link mean is, it is going to compute the average of all the points, average of the distance between all the points A comma x. Like from, if I consider this single point, the distance between this point to all the points in the cluster, we are going to check out. If I consider this, the distance from this point to all the points in the cluster. Okay, if I consider this, the distance between this point to all the points in this second cluster, and it takes the average of the values. Okay, it takes the average of values, and that is considered to be the average link. The next thing is Ward's minimum variance. So here Ward's minimum variance is the difference between the total within the cluster sum of squares for 2 clusters separately and within the cluster sum of squares resulting from merging 2 clusters. So here this is applied for small clusters. So Ward's minimum variance is applied for small clusters. So here we are going to take sum of squares of all the distances in a single cluster with the sum of squares of all the distances between 2 clusters. We said in the previous videos about this intra-cluster and inter-cluster distances. So here we are going to consider this intra-cluster and inter-cluster distances, and we are going to compute the Ward's minimum variance. Okay, so this Ward's minimum variance is given by dw of A comma B is equal to NA NB DC of A comma B into, sorry, not into, it is divided by NA plus NB. So this is the equation given for Ward's minimum variance. So here dw of A comma B is the Ward's minimum variance. So this is the Ward's minimum variance between 2 points, 2 clusters A and B with NA and NB objects in them respectively. So NA and NB are the number of objectives in A cluster and B clusters respectively, and DC of A comma B is the centroid distance between the two clusters. So here this is the centroid distance between the two clusters and divided by the total number of objects including both the clusters. So here Ward's minimum variance is given by dW of A comma B, where A and B are two different clusters, given by NA and NB, the product of NA and NB, which gives the number of objects in cluster A and the number of objects in cluster B, along with the distance between the centroids DC of A comma B, the distance between the centroids of A and B cluster, whole divided by the number of elements in A plus number of elements in B. So if you compute this, we are going to get the Ward's minimum variance value. Okay, so while we are doing this agglomerative and divisive techniques, we are going to take up any of these things. Okay, any of these 5 different algorithms we are going to check out for computing the distance between the two clusters. So now we have seen with the agglomerative testing, we have seen with the agglomerative method of hierarchical clustering. So now we will see with the divisive clustering. So what we did in agglomerative, initially we had 5 different clusters for 5 different elements and different clusters for n different element. But in divisive clustering, it is exactly the opposite of agglomerative. The end point of the agglomerative clustering is the starting point of the divisive clustering. For all these n different objects, we are going to have a single cluster. We are going to have a single cluster. Okay, so now from this single cluster, we are going to divide this cluster based on the distance between the 2 points. So if I consider the distance between these 2 points, the farthest distance will be removed out or popped out. So if I say, it will be like this. Again, in the next step, this would be here, this would be like this. So starting from all the elements in a single cluster to n different elements with n different clusters. So we call this as divisive clustering, or we call it as Diana clustering. This is a top down approach. In the top we have one single root, from there we are going to have at the leaf level we are going to have the different elements separated. So but in agglomerative approach we call it as bottom up approach. From a single elements we are going to have a single cluster. So that is called as agglomerative, and this is this Diana or the divisive method. Okay, so in this divisive method we have 2 different types. One is monothetic and one is polythetic. Okay, this Diana approach is divided into monothetic and polythetic. What is this monothetic and polythetic? Mono means single, poly means more than one or multiple. So if the division of the cluster is being occurred only on considering single attribute, we call it as monothetic. Okay, if the cluster is being divided based on a single attribute at a time, we are going to consider it as monothetic. If there are multiple attributes considered while dividing the clusters into different parts or different smaller clusters, we call it as polythetic clustering or polythetic divisive clustering. Understood? So I will repeat, if the clustering division is happening on single attribute at a time method or single attribute at a time priority, we call it as monothetic. If the division of the clusters is being occurred on multiple attributes at a time, we call it as polythetic clustering method. Okay, so here we are coming to the end of this things. So summary of hierarchical method. So there are different advantages of this hierarchical method when compared to the partitional method. So the first thing is, this can provide the more insight into the data by showing a hierarchy of the clusters than the flat sets. Okay, than the flat sets. We are going to get an insight of the data set which has been given to you for the clustering method, and then in some applications only proximity data is available, and then hierarchical approach may be better. So hierarchical methods can provide clusters of different levels of granularity. So if you have a data set and if you want the different levels of granularity into it, so you can go for this hierarchical method. If you are going for very single type of granularity, then you can go for partitional methods. So the disadvantage of this are, this does not include a mechanism by which objects that have been incorrectly put into a cluster may be reassigned to another. So when we considered partitional methods, there we could reassign the objects onto different clusters if at all it was incorrectly put. But in hierarchical method we cannot do so. Once if you have created a cluster, then it is done. You cannot reassign any object to different clusters as you could do that in partitional method. The time complexity of the hierarchical method is given by big O of n cube. Big O of n cube. This is for hierarchical methods. So if I consider the distance matrix, it is given by big O of n square. Big O of n square. So this is for distance matrix and this is for hierarchical methods. This big O of n square becomes very large for very large number of objects. As the number of objects increases, the complexity also increases for the distance matrices. So different distance matrix and scaling of data can significantly change the results. So if I am using single link for a particular distance matrix, the result might be different. If I am using centroid matrix, centroid algorithm, then the result might be different. So this is what this statement says. So the next thing is, we have density based methods. So density based methods are the clusters which have high density collections. So it is based on the number of points in a given radius of the centroids or clusters. So we need to have minimum number of points at that particular radius from the centroid to the cluster outliers. So if there is no minimum point available, then we cannot check it out as a density based. So we have one method called as dB scan. Okay, dB scan. So dB scan means density based spatial clustering of applications with noise. We call this as dB scan. This is one of the very important application which we can give in for density based methods of clustering. So here the neighborhood, the core objects, the proximity. Three things come under here. Four things. One is the neighborhood, core object, proximity, and the connectivity. So these are the four objects which come as a concept when we consider this dB scan. So the neighborhood of an object Y is defined as all the objects that are within the radius R from given Y. So as I said, a minimum number of points to be present from the given point to the radius. So whatever the points which are present, we call it as neighborhood. The core object, an object Y is called a core object if there are n objects within its neighborhood. If there are any some required minimum points surrounding that particular point, we call that particular point Y as a core object. Next is proximity. Two objects are classified or defined to be proximity to each other if they belong to the same cluster. If any two objects belong to the same cluster, we call it as proximity. And then the connectivity, two objects x1 and x2 are connected if there is a path or chain of the objects from x1 to xn such that xi plus 1 is the proximity of the object xi. So these are defined like this for the new things. So this is something about your clustering methods. So here we are going to end the clustering techniques, so clustering analysis methods. So what all we studied, what is clustering, where clustering is involved, what are the basic applications of clustering, and what are the different distance computing techniques, what are the different types of data that can be clustered, and then we studied about the partitional clustering, we studied about the hierarchical clustering, we studied about the k-means algorithm, we studied about solving the problem in k-means, we studied about hierarchical clustering, in which we studied about two different things, one is agglomerative and divisive techniques. So we saw what is agglomerative testing, we saw what is divisive clustering, and then we discussed about the 5 different approaches for distance computing between the two clusters. The 5 different methods are single link, complete link, centroid algorithm, and then we saw about the average link algorithm, and then the last one was Ward's minimum variance algorithm. So here in the single link, it will be the smallest distance between the 2 points, or the smallest distance between the point 1 in cluster 1 and the smallest distance between 1 point in cluster A and 1 point in cluster B is found out. So that is a single link. In the complete link, the farthest neighborhood algorithm, which we also call it as the longest distance between the two different clusters, have been found, will be checked out. And in the centroid, the distance between the centroids will be checked in. The average link, from every single point in A, we are going to check out the distance for every single point in B cluster. So that is average link. What's minimum distance, what's minimum variance algorithm? Here we are going to compute the minimum variance of the algorithm by checking out the intra distance and inter distance of the clusters. The Watt's minimum distance is given by dw of a comma b is equal to Na, where the Na is the number of objects in cluster A, and Nb is the number of objects in cluster B, multiplied with the centroid distance between the centroids of cluster A and cluster B, dc of a comma b, whole divided by, we are going to have the total number of objects, that is Na, the number of objects in cluster A, and Nb, the number of objects in cluster B. So that we saw how agglomerative clustering works by taking an example of 5 different elements. We saw how divisive method works by taking the example, and then we discussed about the advantages of hierarchical clustering, and also we discussed about the disadvantages of this hierarchical clustering. So this completes, we also studied about the DB scan, density based clustering, along with the DB scan. We just mentioned what is DB scan here, so further readings can be done from the materials. So this comes to the end of the 5th unit of the data mining clustering analysis methods. Thank you so much.